Hey, Kiwi Decoders, this is Michael. We're going to be talking about authentication today. It's probably not going to be a solo. I believe Jan will be showing up very soon, but if it is, we'll still go over authentication. I want to make sure that we know who the user is when we're using a replicator, and then for future episodes, we'll talk about what the user can do, authorization. And in Janaga, I separate the idea of authorization from between the writes and the reads. So authorization is just the write side. What can you do? And then there's another idea that's distribution. That is, what can you see? What can you read? So we will be covering probably distribution next, because authorization is working in Janaga. Distribution is not yet working, so we'll talk about what it means to set up distribution rules and get that working, and also to upload distribution rules and authentication or authorization rules to the replicator as a service. And Mr. Biscuits is looking around, wondering, where's Jan? Oh, here he is. Good morning. Good afternoon. How do you do, sir?
Doing fine. No, Discord said join voice, but no camera. I thought, what's happening with my camera? But
oh,
so yeah, Michael is gonna be waiting. So I clicked join voice. Finally, I say let's find out for the camera later. But apparently it does work.
Yeah. They call these voice channels, even though they do also have a camera. I think that might be just a legacy name.
Yeah, but usually it doesn't ask that. Doesn't matter.
Yeah.
It works.
Yeah.
Getting used to software. Huh?
Yeah. I know. It's crazy stuff.
Yeah.
We need to fix this problem.
We still have a lot of other problems to fix, which are more urgent.
That's true.
Yeah.
Yeah. So what have you been up to since last we spoke?
Let me show you a few things. Okay, that should perhaps be readable. Is it?
It is.
Right. Let me first, because I swapped back between my own definition here of what was it, the SQL query, the SQL query tree, which I used long ago. So comment that out, and then let's find, that should be right here, Michael's definition, which is much more compact and much more elegant. Uncomment that, and then comment this one and uncomment that one. So the only problem now is that he's complaining in my code all the other things, because I didn't integrate your code yet, like the SQL specification parser, all that stuff. A little bit I did this week was just finish the execute query tree.
Okay.
So wrapped my head around the aggregate function, and the map from last time, which I made select. But so, because the things before, the things behind are not working with your definition. It should. Oh, it was,
I think we had to. Yeah, you're back.
I think it should be working now. So we do this aggregate over result set rows. So a result set row is what we get from the database.
Yes. Yeah, that makes sense.
Yeah, actually, a data row is what we get from the database.
Oh, okay.
And that one converted into an immutable dictionary with the column names, that becomes a result set row. Yeah, you see, it's an
Right.
immutable
Okay.
dictionary of int plus result set fact.
Right. Yeah. So the
That was
int
it.
represents
Yeah.
the fact index within that particular query,
Mm-hmm.
and then the result set
Yeah.
fact has the hash ID and data.
Mm-hmm. And my fact, that one I got last time
Yeah.
already. So now I just add the fact and the index to the accumulator, which is just the immutable dictionary.
Mm-hmm.
And then the whole thing together for one data row. So one data row is just one row that I get out of the database, becomes a result set row.
Yeah.
And then finally I get all these result sets. So combination of all the result set rows, I get them into a new result set tree,
Mm-hmm.
where I wait. I already forgot it. I made a new result set tree. Yeah.
Yeah. Yeah. So this is
Okay.
recursively adding the child result set trees.
But I'm missing a part. Did I delete something? Wait. There's something wrong here. Because it's just a new one, but
Yeah.
no.
Okay.
I think there should be an add here.
Yeah. So it's like it's collecting the rows for this query, but then it's just creating a brand new result set tree to collect the children.
Wait. Did I delete something on the way, or did I not implement it? But it was there before. So that's a new.
Yeah. Does the result set tree constructor take the immutable dictionary?
Wait. Let me think again and
Okay.
get back to the papers.
1 second.
Result set tree. Result set tree was my immutable list. Yeah, something is gone. Something is gone.
Yeah.
Oh no.
Yeah, that result set
No.
variable that has the immutable dictionary in it, and
Wait.
yeah, something needs to happen with
Because
that.
so result set. So what I had here was my result set tree dot my result set, and that was an immutable list, and that must be result set. But there we had a problem, because this is an immutable list, this is an INumeral, so here I had to add two immutable lists like that.
Yep.
And then it was working. And I know that it existed because I was having trouble with that one before. But I think I just deleted that line.
Okay. That looks more like it, yes.
Yeah. And then to that result set tree, I walk over the child queries in the SQL query tree.
Mm-hmm.
I execute recursively this same execute 3, same connection, but this time with the child query, which is a SQL query tree in itself.
Yep.
At least the value of it. And then that child result set, I add it to the result set with the correct key for the dictionary.
Perfect. Yes.
And so now I'm going to save it. And so I return a result set tree, and that should go into your code then. So I get the SQL query tree from you, and I return you the result set tree. Now I should only test it out now to see that it doesn't work and that I forgot something.
Well, it looks pretty good so far. So I have confidence.
I always have confidence in myself, but it always turns out not to be working initially, but in the end it will.
Yes, yes. Yeah, people often say, I'm surprised that ever worked. But then, of course, you don't stop while it's not working. You keep going until it works. So yes, of course, things eventually work.
Yeah. It always works, but it takes a lot of time in my case.
It does. And in everybody's case.
So, yeah. So let me check. You had the GitHub. GitHub. No, that's the wrong one. Jinaga.
Yes, in the Jinaga organization.
And then it was Jinaga.net, I assume.
Correct.
And then I should go to. You had a branch for that. You explained me last time, but I forgot it already.
Yes.
Was it the SQL query branch 2 weeks ago?
Yes, that sounds right.
Okay. So. Okay. So in that one, you have a SQL store, SQLite there. Okay, there I can copy in my code. You have a connection factory. Oh, you already have a lot of data in it.
In the SQL, let's see. Taking a look at the branches now. So, yeah, the SQL query branch.
Okay, that's an old copy. Yeah, that's an old copy I think you used there.
That's right. Yeah, okay. There's a SQL database branch and the SQL query branch. SQL database is an old branch, but SQL query has been updated 2 weeks ago. So
okay, let me check. SQL query. That's the right one, huh?
correct. Yes.
Yeah. Okay. Okay, and because you have the connection factory. Yeah, that's some of the code you copied in already. All right. I will update that with the latest version then. Yeah.
Yes. Yeah. This is based on the branch that you already created the pull or updated with the pull request. So yeah, connection factory is going to be based on that branch. So when you when you have all those branches together in the Git repository, you should actually just be able to do a merge, and it has the right baseline.
Did you manage to run any tests already with that old connection factory or not at all?
I haven't run any connection factory tests, no. So I have written some query generator tests. So this is the part before, before it calls the code that you were just talking about. Where given a specification, it generates the
Mhm.
SQL query tree.
Yeah, join to successor, join to predecessor. Yeah, indeed. But so for the moment, there has not been a complete round trip through the database.
Correct. Yes.
Okay. Hmm. That that's gonna be nice to try.
Yeah.
I look forward to try that.
Yeah. I have
Um,
confidence. I think this was. I think this is going to work
yeah.
first time.
I'm sure the code on your side, yes. The one on my side. Okay. We can we can we can always go and look up the facts manually, feed them in, and continue.
Mm-hmm.
Okay. No. Okay. That's gonna be my next step then. Integrate that little code that I did and integrate that in your bunch of code and make it and try to make it work.
Yep. Yeah. It's so yeah. The first part of that was the most complicated part, and that's already tested.
Mm,
The back half where it's stitching all of the results back together from the tree. That's just derived from the JavaScript version of that algorithm.
mm,
So even though there's no tests around it yet, I'm pretty confident that once we get a result
mm,
set tree in there, it's going to either work right off the bat or tell us very quickly what I got wrong.
mm. I will try that out. But anyway, even these very small portions of code with a select and an aggregate and all these structures of data,
Mm-hmm.
um, it really needs some concentrating before. Because last time I said, okay, I got it. And so this time I looked at it, I said, no, I didn't get it anymore. And it took me a while before I say, yeah, I get it again.
Yeah.
Um, but I find it very difficult to imagine the structure behind it.
Mm-hmm.
Um, and on one hand, it's very good to have the JavaScript implementation and then the .NET, but then the names are a little bit different. The data structures are a little bit different.
Mm-hmm.
Um, I think I don't have the correct brain for that, but never mind.
Yeah, and it's not very helpful that the way that structures are organized in JavaScript is actually very different uh,
Mm,
from .NET. So dictionaries, um, you in JavaScript, you just use an object to represent a dictionary.
mm,
Um, there
yeah.
is a dictionary type. It's actually called map, I think, is the name of the type. Um,
Mm,
but it really doesn't have too many advantages over just using an object. So that's what I will typically do. Um, and then another big part is that in JavaScript you have um, a common pattern is the discriminated union. So if you've got
yeah.
a bunch of different things that it could be, you just um, have a discriminator
Yeah.
in the JavaScript object, and then you just say if it's this, then the rest of the field should look like that. Um, whereas in .NET, you create an object hierarchy in order to accomplish the same thing. Um,
Yeah.
so it's yeah, and
Which is
then
actually more complicated in .NET.
I think so too. Yeah.
I find. Yeah.
Mm-hmm.
Because I was actually surprised if I look to your definition of the SQL query tree.
Mm-hmm.
Um, actually, you got it quite. Wait. Um, if we go back to this one, you got it in three levels: SQL query tree, specification query tree, and the specification label.
Mm-hmm.
And if I go back to what I made long ago to do the first testing, I had a specification label here, specification SQL query.
Okay, yeah, the
And then I
named
had
SQL
this
query.
named, yeah,
Yeah, and that
and the
was
SQL query tree.
yeah, and that named SQL query tree was matching the JavaScript way of thinking about it, where
Mm-hmm.
uh, there we go, where you can take an existing structure, an existing type, and then union some other type, and then that basically adds fields to it. And
Yeah.
and so using that, I was adding a name to an existing type. Um, in .NET, you could kind of get away with that using inheritance, but that feels wrong. That's the kind of inheritance that's inheriting implementation and then augmenting it rather than saying it is a kind of thing.
Mm-hmm.
Um, so so yeah, but basically that was um, to give a name to a thing that I wanted to put into a list to preserve the order. Um, in this case, though, I think what ended up, yeah, the order doesn't matter. So this ended up being in a dictionary by name instead of having the name
Yeah.
attached to the object. So
Mm-hmm.
yeah, just a difference in language causes a difference in the data structures.
Yeah. Anyway, it's very interesting to see how you implemented the structure. What should be the best way
Mm-hmm.
to do it. Uh, so it was not too bad that I tried it before.
Yeah.
Where was the code here? Okay, good. You continued to work on the um, what was the name already?
Did some authentication stuff, signing in with
Wait,
Apple.
yeah. Okay. Wait, I'm gonna end this sharing.
Okay.
Stop streaming. Yeah.
And so let's take a look at. Okay, make sure I've got the right view. There we are. Perfect. Okay. Let's take a look at the Monster Hotel replicator. So what I did was rather than go straight at the multi-tenant replicator, what I wanted to do was to publish a replicator that that worked in the way that I wanted the multi-tenant replicator to eventually work, but still not have it be multi-tenant quite yet. And so yeah, I took one of my example projects, Monster Hotel, which I created for the React Native Pluralsight course, and said, okay, what if Monster Hotel was a Janaga application and it had a replicator? And so this is the Monster Hotel replicator. Um,
Okay.
so we will walk through step by step what this is doing. But before we do that, I want to kind of start at the end. Start at what this thing does. So we have Postman, and I've created a Postman collection for the Monster Hotel replicator and set up authorization. So this is the experience that that I want the end user of the replicator as a service to have, is they should be able to start up Postman and configure a few things here, and then immediately start using the replicator. So do all this without, without having any of their own code written. Just a second, making sure that I'm actually streaming. I think I am. And here yeah. It's says connect to the software. All right. Yeah. It's been going. Okay, good. All right. Yeah, I just wasn't logged into the browser even though I was streaming, so it's yeah. Okay. Okay, so we've got the Postman collection. We set up authorization with the Postman collection, and in here we authorize with the replicator. So that is one really important distinction. So I was kind of thinking through as I wanted to support different ways of authenticating. Authenticate with Apple, with Google, with your Microsoft ID, maybe even if you wanted to set up an Auth0 subscription. Yeah, I'll let you authenticate using Auth0. That way you've got your own usernames and passwords. Azure B2C, I think there's a new version of Azure B2C that's coming out soon, so I'll try that one out. So all these different ways that you can authenticate. But as an application developer, so I'm focusing on the front-end developer. So this is somebody who is comfortable with, in the case of JavaScript, React or React Native, and in the case of .NET, Maui, Blazor. But I don't want to force them to have any kind of backend code whatsoever. So they shouldn't need to build a Node or a ASP.NET application and deploy that to Azure in order to get anything to work. The replicator should be everything for them. So, given that set of skills and those constraints, I decided that you would set up your authentication between your application and the replicator, and then the replicator would take care of authenticating with all of the other backend systems. That way, those backend systems that do require some kind of server-to-server communication, I've got the server. And in fact, I think all of them that I want to support do require a server, or at least in the case of Apple, you can do direct to client, but there are some restrictions there. So this is the callback URL for your client application. And in fact, I just put in a URL that I don't actually have a client using that callback URL. But that is part of the OAuth protocol that we'll be using to authenticate between the application and the authentication, or the replicator. So in the case of a React Native application, for example, you'll still have this callback URL, but it won't actually go anywhere. You just tell React Native, hey, sign me in, go to this auth URL right here to do that, and then when the browser wants to redirect to this one, that's basically just a signal that you're done. So the mobile applications intercept those redirects and say, that's the one, and now call back to the application. So, but in the case of a React application, then it truly does redirect the browser, and then the browser is able to pick up the authorization code. This supports both of them. I chose authorization code with Pixie, PKCE, and that is an OAuth 2 protocol that does not require a backend. If you have a backend, then you can keep this client secret a secret, because only the backend needs it in order to validate that it's talking to the authenticator and vice versa. But if you don't have a backend, like I don't want the Monster Hotel app itself to have a backend, then it's actually counterproductive to have any kind of client secret. And that's because you would be shipping that with your front end. So Pixie is an alternate way of doing the authorization code handshake that does not require a client secret. Instead, it makes up a verifier when it first starts the handshake, and then when we get back the authorization code, we can use that verifier to say, all right, turn that into an actual access token, and yes, this really is me. So so it's almost as secure as having a back end of your own, but different in one very important way. So I'll get into that very important difference in a little bit. But first, let's see this thing work. So it's going to hit this auth URL, and it's going to do that initial authorization handshake. And then when it's done, it's going to then take the authorization code that it gets back, and it's going to post this to this token endpoint. And that will then return an access token. So these are the settings that the application developer should be able to set up, and none of these are secret. All of this stuff can ship with the application. So let's get an access token, and this opens a little browser over here that's saying, hey, sign in with Apple. I'm going to, so that we can see everything that's happening, open up the DevTools for this little window, and we can see, let's go to, for example, the network tab, and that way we can, let's preserve the log, so we can see everything that that bounces back and forth. Okay, so let's sign in with my Apple ID, Michael at qdcode.com. Zoop. And then the password, which I will not read out aloud. Let's come here and let's copy my password. All right. Oop. And now this is the first time that that the user logs in with their Apple ID, so they get their two-factor auth, all that stuff. 3. Sure, I trust this browser. And saying, hey, this is the first time. What name do you want to give to the application? And do you want to share your email or hide your email? So all that stuff, that's just regular Apple stuff that you only see the very first time that you do this. So we share, and authentication complete. If you look right here, I got back an access token. Well, this is obviously a fake access token, but it completed that that handshake where Postman talked to the Replicator and the Replicator talked to Apple. The user saw it as just logging in with Apple, but then this access token that you get here is a Replicator access token. So we'll use that token, and now that's added here, and that will be part of the authorization header for all of the requests. So just doing this, you should be able to create a replicator, configure these things, and then start start populating it with Janaga.write, and just play around with it before you even have any code written at all. So let's take a closer look at oh wait a minute, did it, yeah, when it closed the window, I think it took away the I think it took away my debug window as well. Well, let's go ahead and walk through it. What does it look like the second time? There we go. Authenticate with the browser. Let's show the dev tools. This time we'll actually keep this around and take a look at the contents. Same password. And so this time it doesn't ask me what name do I want to share, what email do I want to share. We've already established that relationship with Monster Hotel. So there it goes. Oh, okay. Well, during debugging, I got all sorts of errors, and I could see the back and forth. Here we go. This might help us keep it around. So if we authorize using browser, then I think it will actually use this browser instance to do the same thing. And so I should be able to hit F12, get my network tab open here, and this, I hope it doesn't close this tab. Oh, and here's my other Apple ID. I haven't tested with this one on this one. So we'll go through the initial step again. Yeah. Sign in with Apple. This one is giving me the experience of, this is the Apple ID I use on my phone, so it's, my phone is saying, hey, somebody's trying to log in, so I hit allow, and then it says, here's the code to type in, and I want to trust this browser, and that's okay. And again, what name, what email do you want to share? So please don't close the tab. Oh, okay. We got an error. Well, that keeps the tab open at least. Okay.
It's an advantage.
Interesting. Okay. We'll dig into that in just a second. But yeah, let's kind of walk through what happened here. So we start by the part that you don't see is that when Postman hit this, where's Postman? Here's Postman. When Postman hit this auth URL right here, this is the Monster Hotel Replicator auth URL. So it's using auth2, do the auth portion of it. And so that's Monster Hotel Replicator, that is not Apple. And so that endpoint did a redirect to appleid.apple.com and said, all right, sign in with Apple. That's how this particular replicator was configured, so sign in with Apple. There's another sneaky little thing that it did, is it took all of the query parameters that you sent in order to initiate this authorization, and it shoved those into some cookies. And those cookies are in the Monster Hotel Replicator domain, so they're squirreled away there. And then when we go over to this other domain, we don't have that information, but we'll come back and we'll be able to pull that information back out. So
the server will know that you are still the same person.
Yes, exactly. Yeah. I'm still thinking about whether I want to use cookies to just store all of those parameters as they are, or if I want to instead use a session and store that information server side, but then have a session cookie that identifies which session. I don't think, since it's all flowing through the browser anyway, and these are all HTTP only cookies, I don't think that I'm opening anything up by storing them in cookies. And not having a session means that there's less load on the replicator itself, on the server. So
the session ID, is it also stored in a cookie on the browser or not?
Yeah. The session ID would be stored on a cookie on the browser, and that would just be an opaque reference to the storage that's that's on the server.
Does that mean that people who don't allow cookies, they will have no access at all?
Yes, and that's going to be true about all of this. This relies on being able to use cookies. Um, yeah, all of the uh, well, let's see, is that true? I was about to say that all of the authentication methods need cookies, but that's not true.
I'm pretty sure one of the websites where I log in regularly, they use session IDs to to know what session you are on.
Mm-hmm.
But I think I don't allow cookies, or I didn't for that website. So
Yeah, I'd be curious to know how they know which one is your session. Um, Perhaps they are sending a session token or session ID back in uh, every URL. So it's part of the query string every time you
um,
navigate through.
I was when I was working on that scraping project.
Mm-hmm.
The moment I logged in, it gave me back, or just before it gave me back a session ID. Um, I I think I stored it myself to send it back with every
Mm-hmm.
request again.
Okay,
Um,
but you did
so
not send it as part of the cookie header.
I don't know anymore.
Yeah.
I will have to look it up. uh, Wait, perhaps I can see it immediately here. Um, oh, yeah, Discord is against there. Let's have a look to that code.
By the way, I just saw the
Yes.
reason for the error right here.
Yeah, because that was a PHP session ID. So when I logged in, I got a response. From that response, I said, no, it's not F12 here. Get raw cookies, No, the session ID was actually one of the cookies I got back.
Okay, so it sent
So
back a set cookie
yeah,
response header.
in the header,
Mm-hmm.
it gave back a set cookie, and then that was an array of cookies. And for every cookie, I checked whether the name was a PHP session ID or SES ID.
Mm-hmm.
And if it was that, then I returned it. I'd go to references. But so yes, it should have been stored as a normal cookie on the drive. And in my software, I just put it in a variable, and I kept
Yeah.
it in a global variable. But I think on the browser, if you do it on the browser, it's just stored on the disk.
Yeah.
So I'm wondering if you disable cookies, whether you can still log into that website.
Yeah. I'm guessing probably not.
Because all these things, we are so used to work with it.
Yeah.
Wait, how do we set that I don't want cookies at all? In Microsoft Edge, it should be in privacy, I guess. Just search for it. Cookies and data stored. Allow sits to save and read cookies. Okay, I just disabled that. Um, let's see whether that works. Whether I can log in. Ah, il says les cookies ne sont pas acceptés. Veuillez changer les options du navigateur. And in English, that means you didn't accept cookies, so please change your options. Otherwise, no way to log in.
There you go.
Okay.
Yes.
So it's clear. It's clear.
Okay.
But I thought I disabled cookies, but apparently not. Okay, it said cookies back. And now when I try to log in, okay, now it works.
Excellent.
So that probably means that your session ID probably gonna use cookies.
Yes. Yeah.
And if you don't allow cookies, you cannot log in.
Yep. Yeah. So it's just a difference of like here you can see this is the callback that Apple is making back to Monster Hotel Replicator. So it's calling the auth Apple callback endpoint, and the very first thing that it does in the response headers is this clears the cookies. So you can see auth client ID, auth code challenge. All of these are different parameters. If I were to switch to sessions, basically this would just be clearing the session cookie, and all of these parameters would be stored in the database on the server side. So yeah, it's just a matter of do I want this stored on the client side? Do I want to store it on the server side? If I store it on the server side, then you just wouldn't be able to see these individual parameters, but you could have seen them when it did the they were in the query string that you initially posted, or actually you did a get with all these things in the query string. So yeah, it's not that like they're more tightly protected than they would be if they were in these cookies. And these are all HTTP only cookies. So the JavaScript code, even if you were able to do a JavaScript injection attack, you wouldn't be able to see the values of these cookies. So I think this is good, but yeah, I'm still going to do some research on that. Okay, so all of this stuff up here is Apple doing its thing. So all of these are apple.com URLs. This callback right here is the first one that gets back to Monster Hotel. So when Apple is done with its authentication and it says, okay, I know who this is, then it posts back to to this endpoint, and it sets it does set a cookie of its own, but yeah, the real fun stuff is in the payload. So it's doing an HTTP form post, setting state, code, ID token, and user. And state, I believe, is the same state that I initiated with, so I can validate that. I'm going to have to double check that. I'm not doing that state validation yet. And then the code is a code that I can call Apple back with in order to get this ID token. But here on the I'm also getting back the ID token itself. This is a JWT token for Apple. So if I take a look inside of this, go to the debugger here, paste that in. So I can see this is signed by Apple's. Well, it's signed using an RSA key pair. The RSA key pair that it uses is actually one that that I have the private key for. So so yeah, I can use that to validate the token. So here's the issuer. The audience is my particular service ID, and the subject right here, that is the identity of the user. So that subject is what I will then use as the user ID for authenticating with the replicator, and the provider for that subject will be Apple, and that will distinguish, that subject will distinguish from other users authenticating with Apple, and then that provider separates that identity space from Google identity and Microsoft identity and all that stuff. And then along with this, I get the claim, which is an email address that will now redirect to my real email address. Keep it hidden from the application.
And
yeah.
What was the use for that? That you can use this in your application so that people can send you mail, but they don't have your own mail address?
Yes. Yeah, and you will see that for every application that you sign in with Apple, you'll have that option to send your real email address or to hide your email address. If you say hide, then Apple uses this relay.
And that relay email address will be the same every time you authenticate?
For this application, yes. If you authenticate with Apple ID using a different application, so it's a different audience, then Apple will set up a different relay.
Okay.
And that's pretty cool, because then you know, okay, I've only given this particular email address to that particular application. And so when I come in here and manage my Apple ID, and then I go to my applications. Oh goodness, it is really making sure that it knows who I am. Yeah, so then you can take a look at your sign-in with Apple, and here's Monster Hotel. So this was the email address that it gave to Monster Hotel, and if I stop using sign-in with Apple, it's going to stop relaying messages from that email address. So yeah, that way I get to control who gets to send me email. And if that email address leaks because somebody sells my information, hey, then I stop my relationship with that particular application that sold my information. Say, nope, you can't have that email anymore. So yeah, that's a sign-in with Apple feature. So as far as what the Janaga replicator wants, it wants your ID. So it wants this part, and it also wants the name to display in the application. So those are, it sends just that much profile information back to the application in response to login. So the replicator, so far, I don't have any plans to use this email. But you can see the name is not included here. If I go back here, I see the name and the email are posted back to the callback. So basically, I have to grab this profile information from Apple as it posts back and associate that with the Janaga user. And then that way, when Janaga logs in, I can say, hey, this was the name. Now, one kind of annoying thing is Apple will only send the name the very first time. So this was the first time I logged in with this particular Apple ID, so there's the name. From that point forward, it doesn't send it to the application.
So you have to store it yourself.
Yeah. Yeah. Which in and of itself is not a problem. The problem is that you're debugging this thing, and the first time it's not going to work. So the first time you're
Ah,
definitely going to miss this information.
mhm.
Then you finally get it working and you're not getting the information back anymore. But the trick is to just go back here. There it is. Go back here and stop sign in with Apple. Boom. All right. Now it'll do it again the next time I sign in. But it'll give me a brand new email address and a brand new ID. So
Mm.
yeah. So yeah. So yeah, this is the callback from Apple back to the replicator. Now the replicator needs to basically take all the stuff that it had stored in these headers in these cookies and complete the OAuth 2 round trip with the application using Pixie. So it knows the application that it's talking to doesn't have a server. It's basically playing the part of the server. So the reason that we're getting this error here is I can see the auth response that I'm getting. It has the client ID, that is correct, and so I'm able to look up in my multi-tenant database which client we're talking about here. And then here's the redirect URL. You can see this is https authpostman.io v1 callback. So this is not the callback that I put in here. So this callback, yeah. Callback URL cannot be modified when authenticating via the browser. So instead, you would have to use this one and configure that with your identity provider. But I only did authorize with browser so that we could take a look at this. Most of the time you would not do that, and then it would just use the correct callback URL and everything would complete. So yeah, it's jumping from here to here to here and then back again. So yeah, the important distinction that I teased at the beginning. What you have here is enough information for any application to be able to authenticate with your replicator. And none of this is secret. So you don't have a client secret because you would end up shipping the client secret with your application and it wouldn't matter anyway. All of this information gets shipped with your mobile application or is visible to somebody using your web application in the browser. They could just take a look at at the network and they could see all this information flowing through. So literally, a client is instructions on how to authenticate and how to call an API. And it pretty much has to be because it has to be instructions for the mobile phone or the browser to do that. But that also means that if you don't have a server, then you cannot protect the client. You cannot be certain that only this client can be calling this API and not some other client. So on the one hand, that's good because that means that somebody can just pop these things into Postman, start using the application, and then as they start developing the application, those same settings work over there in React Native or in React or in Maui, and nothing has to change. But on the other hand, it's bad because once you ship an application, to the Apple Store App Store or put it up on a CDN for people to run it in the browser. Well, once you've shipped it, you've shared all that information. Somebody could decompile your application and then write another application that calls exactly the same API. So for the most part, pretty much your application is just a convenience for calling an API. If the user could call an API directly, they would do so and they would have access to all of the features of your application. So pretty much your application is the replicator and the authentication authorization distribution rules that it enforces. Everything north of that, facing the user, is just a user agent.
So that means that we must provide checks so that if they don't use the application, but for example, Postman to connect, that they cannot do anything wrong with the replicator.
Yeah, the problem is you can't write those kinds of checks. There's literally no code that you could write that somebody wouldn't be able to see if it's in the browser or in the mobile app. If you don't have a server of your own, then you can't keep anything hidden.
Yeah.
Yeah.
That's true.
Yeah. If you're doing a web application, there is a little bit of of additional support that you have. Yes, everybody can see that's all that stuff, but they could they yeah. So if they were to basically take your JavaScript code, copy it over to their CDN, and put it under a new domain, then all of those calls would be coming from a different referrer. And so the replicator could have an additional bit of checking in it, which I think I will add, that that says, okay, all of these requests should be coming from this particular referrer or some list of referrers. So these are the domains at which I might publish applications that can use this replicator. So that would go into the CORS header, and then that would also be a check when we are doing the authentication. So yeah, that's a small bit of protection. It's not really a full security measure, but yeah, if you're doing a web application, the browser gives you a little bit of help. If you're doing a mobile application, the mobile operating systems don't give you any of that help. But
Most people, that will not be a huge problem.
yeah, I don't think so. It's that's now kind of a just a reality of how how computers work, how information flows. So yeah, you ship a mobile application, you are shipping the client for your API. So that means it's really important that that a Janaga replicator implement the authorization and distribution rules. So yeah, once I've got this thing ready for production, it's going to have a check in there. If you don't have authorization and distribution rules set up, which also require authentication, then you're not going to be able to turn on production mode, and it's going to limit your rate limit you for just testing. But yeah, if you just ship something with no protection at the authenticator level or at the replicator level, then it's basically like providing the connection string to your database out on the public internet. So those rules have to be in place in order for it to lock that down.
Even then, if people would get into the database, they still have they would still need a lot of time just to find out what the data means, how the predecessors, the whole Jinaga structure.
Yeah.
If you see a Jinaga database, what's in it? What does it mean?
Yeah, that would be obscurity, which is not security, but yeah.
No, but it does help.
Mm-hmm.
Anyway, given enough money, every protection can be reversed.
Yeah, that's true. So yeah, you just want to make sure that a broad attack that you're protected against that, so that you basically can outrun somebody else and the bear catches them. But yeah, a narrow attack um, yeah, there's only so much you can do if somebody really wants to get in. Um, but yeah, I will work as hard as I can to make sure that that it's going to be hard for them to do so.
Mm. Good. That's but that's nice that we have authentication working now.
Yep, yep. At least in a specific replicator. So the next step is to add this to the multi-tenant replicator, which means that then you'll be able to to go to app.janag.com, say I want to add Authenticate with Apple. Then it gives you some instructions. It says, hey, go over to Apple, do this thing, copy these values from there, put them over here. And then in order for that to for that to be safe, I actually need to implement distribution rules. So right now you've got authorization rules which protect what the user can do, what facts they can create, but distribution rules protect what queries they can run, what facts they can read, and without distribution rules implemented in Janaga, then that means that anything that I put into the multi-tenant replicator, somebody could log in with GitHub, access the replicator, and then query for everybody's distributors and pull
Yeah.
that that data out. So part of that data is the private key for the for the RSA key pair that Apple uses. So Apple generates a key pair, gives you the private key, and you use that to validate their RSA token. And so you have to give that private key to the replicator. If you, since the replicator as a service is implemented in Janaga, if you were to do that right now, without distribution rules in place, everybody would be able to see everybody else's private keys. So I'm not going to put that in place until I've got distribution rules up.
That's not good.
No, not good at all.
Okay. I will try for next week to integrate that in the branch, and then we can finally start with .NET. Some first tests.
Excellent. Yes, yes, indeed.
Then
Yeah, and next month we're going to be starting the summer semester of Improving You, and I'm going to be doing a Janaga.net Improving You. So
okay.
yeah, we have till the end of the month to have that in there, because for the Improving You, I want to show them polyglot notebooks. I want to show them the replicator as a service, and then I want to be able to to take this build, probably a Blazor application, maybe Maui, I'm not sure, and show the offline stuff working.
And that's in July?
Yes.
Okay.
Yes. So yeah, I want to demonstrate a whole lot of stuff working.
Mm-hmm. Let's see where we can get with .NET platform, and a first prototype of something with Maui.
Yep. I feel that we're really close.
5 minutes.
Yeah.
Yeah.
We'll have it done next week.
Yeah. Okay, Michael. The weeks are too short. That's the problem. Okay. See you next week.
Indeed. I'll see you then.
Okay. See you. Bye-bye.
Bye.